This is 8.4, Part 1, Real World Problems. I'm going to be following right along in our book, so you can feel free to turn to page 29 in Book B. You can stop the video if you need to get your book out. So we are in 8.4 on page 29. I'm going to use the problems from the book. I'm just going to go ahead and solve them as we go. Okay. The first problem on this page says, yesterday Kyle had some stamps. Well, I'm going to make myself a little note about that. So Kyle had some stamps. I'm just going to use an X for the number of stamps he had because it doesn't tell us how many. So today, it says, today his father gave him 12 more stamps. So today he still had the stamps he had yesterday plus 12 more. Let X represent the number of stamps that Kyle had yesterday. Oh, well, that's really convenient. So this is yesterday. And the second line is today. So it says, now he has 27 stamps altogether. So that means today he has 27 stamps. So an interesting way to think about this is they told us two different values for today. They said, today his father gave him 12 more stamps. Here's that first part. And then it said, now he has 27 stamps. That's why we can put an equal sign between these two things, because it told us he has X plus 12, and then it told us he has 27. So our equation is going to be X plus 12 equals 27. Now it also told us the question, it said, how many did he have yesterday? So basically they're saying, what is X? So what we need to do is solve for X. So here we have our equation. We need to get X by itself. So in order to do that, we need to get rid of this term that's 12. It's plus 12, so if we did minus 12, we could get rid of it. But this equal sign right here means whatever we do to one side, we have to do the other. So we have to do minus 12 on the other side as well. So if I take X plus 12 minus 12, well, plus 12 and minus 12 equals 0. So now I'm just left with X on that side. And I still have my equal signs. And so over here, I had 27 minus 12. Well, that's going to equal 15. That means my X equaled 15. So the answer to my question is that he had 15 stamps yesterday. So I'm going to write that out and then put that in a box. Okay, let's try another one. Down farther on the page it says, in a pond there are 3 times as many koi as goldfish. So he has some goldfish and he has some koi. And in fact, it says he has 3 times the amount of koi. So 3 times the goldfish. Well, let's say that goldfish is G. So it's going to be 3 times the G. Well, if we keep reading, it says, if there are 48 koi. So now it has told us that koi is equal to 3 times the goldfish, and koi is also equal to 48. Then it asks the question, find the number of goldfish. So basically find what G is. I look at this and I think to myself, they told me in 2 different ways what koi was. 3 times G and 48. So that means 3 times G equals 48 because they both tell me the number of koi. So I can make an equation from that. Now I can solve that to find out how many goldfish I have. To do that, I just need to get G by itself. Right there. Okay. So I'm going to go ahead and solve this problem. So if I have 3 times g over here, if I divide by 3, then I'll just get g. Because if I multiply by 3 and then I divide by 3, oh, look at that. They cancel each other out. That's a pretty sweet little deal there. Well, if I divide by 3 on one side, I have to divide by 3 on the other side. So I'm going to do that. So 3 times g divided by 3, well, we can see from here that it's just going to be g left, equals 48 divided by 3. Well, I can do a little work over here as well. So 3 goes into that 40 one time, and I have 18 left over. So that was my cat jumping around. She's pretty excited right now, if you could hear that. Okay, so 3 goes into 18 6 times. So g equals 6. That means I have 6 goldfish. And that's my answer. Now, if you notice, I have my equation right there going down in a line, and then I have my answer there. If I saw your work like this on your paper, it would be very easy for me to tell what you were doing, and you would get the highest points possible. Let's do a few more problems. I'm going to go through some of the guided practice. What you could do is pause the video and do the guided practice yourself, give them a try, and then you could watch me solve them, and that might really help you. I'm going to do number 2 from the guided practice first. So it says that, here's number 2, so that says Carlos thinks of a number. So some kind of number. I'm going to make that X. When he adds 17 to it, the result is 45. So what that's saying is, if he has that X and he adds 17, it's going to equal 45. The result is 45. And then it says, what is the number that Carlos thought of? So they're asking, what is that X? Okay, I'm going to write that a little larger so we can work with those numbers. Whoops, equals 45. I better fix that. That looks a little strange. Here we go. X plus 17 equals 45. Well, I take a look at that and I see I have that plus 17. So I need to get rid of that to get X by itself. So if I subtract 17 from each side, then that will take care of that 17 that's there. And then I'll just have that X. So I'm going to do that. And then I subtract 45 minus 17. I'm going to just do my work right over here. I need to borrow, and I get 28. So the number he thought of was 28. Whoops. The number was 28. I'm going to put that in a box. Okay, let's look at number 3. Sylvia bought some blouses and t-shirts. She paid a total of $63. I'm going to write that down. The t-shirts cost $29. How much did the blouses cost? Oh, so we want to know how much the blouses cost. So we'll make that X. So we can do this a couple of different ways. We can say that X equals that 63 minus 29, or we could say that the t-shirts plus the blouses, or the blouses plus the t-shirts, equals a total of 63. Either way would work. I'm going to show you how that works. So I'm going to do my work over here to the left since I've run out of room. So 63 plus, minus 29, I'm going to borrow, and I end up with 34. So X would equal 34 here. Now if I did it the other way, I need to subtract 29 from each side. And look at that. I get that same answer. So you could do that problem either way. It doesn't matter. Okay, let's look at number 4 here. On number 4, it says, Felicia used 153 yellow beads and some amount of green beads. We don't know how many. She used 9 times as many yellow beads as green beads. So that means the yellow is equal to 9 times the green. Or you could just write the coefficient in front of the variable right there. So they've given me 2 different values for the yellow beads. They said that there are 153 in all, and they also told me that there were 9 times the amount of green beans. Green beads, sorry. So that's pretty great because now I have 2 things that are equivalent to each other. Now it wants me to find out how many green beads there were. Well, that's not going to be a problem at all. I'm just going to make my equation. 9g equals 153. And if you'd like to put in this little multiplier, you can, but you don't have to have it. So what do I do to get g by itself? Well, I just divide by 9 on each side. No problem at all. So 9 times g divided by 9 will look like this. And those cancel out. So I'm left with g. And then 153 divided by 9 goes in once there. 63, that goes in 7 times. So 17. So there are 17 green beads. Okay, let's do number 5. This will be our last one. Okay, Ivan had saved some quarters. Now it doesn't tell us how many quarters, just saved, let's say, X quarters. And then it says he spent 50 quarters, which was, oh, wait a second, which was, that sounds like they're saying equal. It was equal to 2/5 of the quarters he started out with. Well, that was the quarters he started out with, so 2/5 X. Well, they did it again. They told us 2 different ways to tell about a number. They said 50 quarters, which was 2/5 of the original, or 2/5 X. So I'm going to rewrite this with the variable on the left. Remember, we've talked about that being the normal way to do it, the most usual way. So that's the best way to do it. Well, we have this 2/5, so I'm going to put this over here on the left so we can look at that. If I want to get rid of that 2/5 and get X by itself, I can multiply it by its reciprocal, because then I can cancel, and that equals 1, and 1x is just x. So I'm going to go ahead and multiply, I'm just going to put it right here in the middle, each side by 5/2. So as we saw in that left hand part there, that's going to make x on the left. And then we need to multiply the 5/2 on the right. Now, if it's easier for you, you can go ahead and put 50/1 so that you can just have everything match and all be fractions. That's no problem at all, because that is equivalent to 50. So I look here and I say, is there anything I can reduce? Well, 2 goes into 50 and it also goes into 2. So 2 goes into 2 once. 2 goes into 50 25 times. And then I need to multiply the top and multiply the bottom. Well, that 25 on the top is pretty easy. I just think, oh, that's like quarters. Well, 4 quarters are in $1, and 5 quarters is 125. And then the bottom is 1 times 1. Now I can simplify that by just saying x equals 125. But then I need to go ahead and write out my answer. I'm not quite done yet. The answer is 125 quarters. And then I put that in my box. And that is the first part of 8.4.